Hi guys, this is Nature Matter 105, part 2, and our topic is just more about ionic substances. So this lovely drawing is a representation of what an ionic solid would look like at the atomic level. You have different cations, and they are bonded to anions, so sodium and chloride. And these lines represent ionic bonds, and that's just, an ionic bond is just an attraction between two oppositely charged particles. Okay, so a couple things about ionic substances. We can measure the attractive force between the particles using something called lattice energy. And lattice energy is just the energy needed to break apart 1 mole of any ionic substance. So essentially the amount of energy needed to break these bonds between the sodium and the chloride of 1 mole of the substance. So 6.022 times 10 to the 23rd of these repeating units. Okay, so another thing about lattice energy is that lattice energy is described, or kind of governed, I guess. Spelled that wrong. G-O-V-E-N-E-R. Governed? Oh well, you guys get the idea. Governed by something called Coulomb's law. And we're not going to go into the mathematics of Coulomb's law. I'm just going to give you a qualitative version of it. And Coulomb's law says that the attractive force between two oppositely charged particles depends on two things. And it depends on the charge difference. What is the difference in charge? And the distance between the particles. Okay, so let's talk about charge difference over here. So we want to remember that the greater the charge difference, means greater attractive force. So we've all heard the saying that opposites attract. We could extend that to think about the fact that the more opposite they are, the greater the attractive force there is. So let's say, for instance, that we're looking at a substance like sodium chloride that has a +1 and a -1. The charge difference there is 2. Like if you're on a number line and you're walking between +1 and -1, you'd have to take 2 steps. If you're looking at something like aluminum oxide, Al2O3, aluminum has a +3 charge and oxide has a -2 charge, where the charge difference is 5. So we would expect this guy to have a larger attractive force, and therefore a larger lattice energy. Okay, so that's charge difference in a nutshell. And then the other thing that we consider when we're talking about lattice energy is the distance between the particles. And we want to remember that the closer the particles are, the greater the attractive force. Okay, and the way that manifests itself is that the smaller particles are closer together, and therefore have a larger attractive force. Okay, so just remember that substances with smaller radii will have an increased lattice energy. Okay, so I'm going to go ahead and just continue this on the next page. And you guys can rewind and fast forward as needed. So let's talk about application of this idea. We're often asked which substance will have a larger lattice energy. So you want to consider two things. And that is, we want to look for the charge difference, of course, and the size of the particles. And as the charge difference goes up, lattice energy also goes up. And as the radius of substances go up, and the lattice energy goes down. So, what we want to look at is that, for example, if we have magnesium oxide versus sodium chloride, and magnesium is +2 and oxide is -2. Sodium is +1, chloride is -1. This guy right here is going to have a larger lattice energy. Because there's a larger charge difference. And what if we're looking at something like sodium bromide versus sodium iodide? So these guys have the same charge difference, +1, -1, +1, -1. And we had to look at instead of looking at the charge difference, which is the first thing you want to check, then you would look at the ion size. And because bromide is smaller than iodide, because bromide is smaller than iodide, sodium bromide would have a larger charge difference, or sorry, would have a larger lattice energy. Okay, so if it comes down to choosing between the two, I always go with the charge difference as the ultimate indicator. So if you had some really small ions that were like, let's say we had sodium and chloride, which are fairly small, and they have a +1, -1 charge difference. And we were talking about a larger substance, like with larger ions like CA3 and P2. Not only does this has a +2 and a -2, so this guy's going to have a larger lattice energy. Sorry about the dogs. That's it. Thank you. Bye.